morning to some of my favorite students. Hope you're having a good morning. You probably haven't been up very long, probably haven't been awake very long, but that's okay. You are ready for math class. Hope you had a good weekend. It was beautiful weather. Hope you got to do something outside and enjoying the sunshine. And I'm pretty sure that you're excited about this week finishing up your math book, finishing up your English book, taking some other tests. This is going to be an exciting week. It's going to be a week of study, but that's okay. You're almost done with school for 2020, at least for this part of 2020. But anyway, let's turn to page 60 on lesson 14. And we are just learning a little bit about, or maybe doing some review about measurements and talking about milliliters, talking about liters, kiloliters, meters cubed is what that means, centimeters cubed, milliliters, just a little bit of a review about that kind of thing. And they're talking about the relationship of volume to capacity in the metric system. So in other words, how much something can hold. That's what they're talking about. The capacity of an object is the amount the object will hold. So in other words, how much can a teapot hold? How much can a teacup hold? And they give you that, but they're putting it into milliliters, kiloliters, liters. We're familiar with liters. We get a 2-liter bottle, that kind of thing, but we don't really do a lot with milliliters. We don't do a lot of that. But that's just something they're going over, and it's some measurements. Not measurements. It's some, what's the word I want? Can't think of it. But it's some things in the metric system that will be good for you to memorize. You'll need it for, I'm not sure if it's probably won't be on your test. I'm not sure about that, but let me see. I don't think it's, probably won't put anything like that on your test because you're just now reviewing it. No, you don't need to know it for your test, but they're just going over a few things. Okay, so they're telling you that a teaspoon, and this is all in your book here, on page 60, and you can follow along. The teaspoon has a capacity, or that means it will hold 5 milliliters, okay? Milliliters is really small. If you think about a teaspoon, that's what you would eat cereal with. That's really little. And a teaspoon holds 5 of those, okay? A teacup will hold 250, okay? Think about a coffee cup. A teacup's probably a little bit, depending what kind of coffee cup you use, but a teacup is usually a little bit smaller, but it will hold 250 milliliters. So milliliter is just really little, okay? A teapot will hold 1 liter. Think about a 2-liter bottle, a Coke bottle. You can kind of picture that, okay? Half of that is 1 liter. A teapot can hold that. A teapot is something that maybe your mom has and she heats water in it to make tea. That's why they call it a teapot. If you look at your picture there, it kind of gives you an idea of what they're talking about. All right, and then they also give you, it says a milliliter fills a space with a volume of 1 centimeters cubed. In other words, that's how big it is, okay? That's how much it takes to fill up a milliliter, is 1 centimeters cubed, okay? So, right here, I have it down. So this is the same capacity, a milliliter or 3 centimeters. So a centimeter is really little, guys. 1 milliliter is 1 centimeter cubed. So that means it takes 3 of these guys to make 1 of those, okay? And 1,000 milliliters equals 1,000 milliliters is the same as 1 liter. Okay, you see it in parentheses. 1,000 milliliters in parentheses says 1 liter. That means they are the same measurement. They equal 1,000 centimeters cubed. So 1 liter takes 1,000 centimeters cubed to fill that up. All right? These are just some things that they have written down in your book. 1,000 milliliters. Where do I have that? I've already said that one. Let's go to 1,000 liters. 1,000 liters, and then in parentheses they have 1 kiloliter. So that means these guys are the same thing. 1,000 liters or 1 kiloliter is the same thing. And they equal 1 meters cubed. 1 meter cubed. Now, if you're figuring volume, we know the formula for volume is area of base times your height. All right, so if you look at the next part, there's a coffee cup there, and it looks like it might have coffee in it. Makes me thirsty for coffee. And you see they have an arrow going up and down, and it says 9 centimeters. That means that's how tall it is. That's the height of the coffee cup. It says, what is the capacity of the coffee mug rounded to the nearest milliliter? All right, so what you have to look at, remember, volume equals area of base times your height. Volume equals area of base. That's what the capital B stands for, and the height. Okay, we have to know what our base is. We have to know what the shape of our base. So, what is the shape of the base of the coffee cup? It looks like a circle to me. I think that's what you guys would say also. It looks like a circle. So, what is the formula for area of a circle? Pi times what? Area. Pi times, Seth? Pi times radius squared. So we've got volume equals pi times radius squared, and then times your height, okay? So this is our area of our base is right here. Because our shape is a circle. That's why we use pi times radius squared. And our radius is it does say on there. Goodness. Mine is it's in the dark part in the coffee, and you can hardly read it. You guys probably have better eyes than I do, but whoo! All right, so what they're saying, if you look in the dark part of the coffee, you have a circle, and this is what it's saying. It's saying 8. What is measurement from here to here? What is that called? Remember, half of it is something, and all the way across is another thing. What is that? Shouldn't have an arrow there. Remember, this is radius, and this is diameter. So they're telling us the whole way across is 8, so that means our radius must be 4. All right, so volume equals pi, which is 3.14, times, probably should use a dot, times radius squared. If our radius is 4, radius squared is what, Casey? 16, and Abigail, what's our height that we need to use? 9. So if we would figure volume, this is the formula we would use for our teacup. Pi times radius squared times our height. We're not going to do it because they've got it all on your book for you, but I just wanted to go over how we would figure it because they're going to get you to figure some some volumes. All right, and they had said to round it to the nearest milliliter, so that means the answer was 452.16. So it's either going to be 452 or it's going to be 453. Which is it the closest to? That's where you would round to the nearest milliliter. Let's go down to number 1. It says, write which measure is more reasonable. All right, so they're going to give you something that's holding something else, like a measuring something. And you have to decide, okay, would the nearest, or would the more reasonable be a kiloliter or a meters cubed, or a liter or a meters cubed, whatever, okay? And what they give us is a soup ladle. Number 1 says a soup ladle. You guys know what that is? That's a soup dipper. Like if your mom dips into the kettle and comes out with a soup and pours it in your bowl. That dipper is called a soup ladle. So how much would it hold? Would it hold 150 liters or 150 milliliters? So let's look at how much does well, let's look here. Well, first thing they say is liters. Okay, so a teapot holds 1 liter. A teapot holds 1 liter. So would a soup ladle hold 150 of those? Could we get 150 liters in a soup dipper? Or a teaspoon holds 5 milliliters. So a little spoon that you eat soup with holds 5 of them, and a big soup dipper would hold 150 of them. Or would it hold 150 liters? One a teapot can hold. I think I would pick probably a milliliter, 150 milliliters. That sounds more reasonable for a soup dipper, not 150 teapots. That's how much it would have to be. The 150 teapots would hold 150 liters. That does not sound right to me. Now, number 2 says a garbage can holds 25 liters or 25 kiloliters. All right, let's look. What is a big garbage can? Think about not just the little trash can in your house. Think about your big garbage can. Maybe you have a bigger one outside that you carry to the end of your driveway and somebody picks up the trash. Remember, did you ever see those kind of garbage cans? Sometimes you see them at the end of people's driveways that they pick up. I'm picturing a big garbage can, okay? That's probably what they're talking about. Does that thing hold 25 liters? Okay, remember a teapot is 1 liter. So could we get 25 of those 25 teapots into a garbage can? I think we could easily get that much in a garbage can. How about 25 kiloliters? Now, let's look at this. There's 1,000 teapots. Let's just say that. That might be easier to think about. 1,000 teapots in 1 kiloliter. 1,000 teapots. That's a lot. Could a garbage can hold 20? It would actually be 25,000 liters, because there's 1,000 liters in 1 kiloliter. So if we're thinking 25 kiloliters, it would be 25,000 liters, which would be 25,000 teapots in a garbage can. I don't think so. We could get 25 liters, so that would be the amount of 25 teapots in a garbage can. That would be the more reasonable measure, 25 liters. All right, let's go up to the top of page 61. And here we have to find volume of the container. And you have a box, basically. It looks like a rectangle box. Maybe a new sweater came in here from your friend for your birthday. That box looks like a gift box. Think about it like that. How much will this thing hold? So again, our formula is volume equals area of base. That can change what our base is. The last time we were figuring a teacup. This time it's a box. So what is the formula for area of a rectangle? That's what that base is. Abigail says it's length times width, and then we have height. All right, so what is our length, width, and height? We've got 10 times 8 times 3. 10 times 8 times 3. That's right. And your label is what? You're figuring volume. It's meters. You went meters times meters times meters. Meters cubed, yes. Now, give the capacity of the box in kiloliters. All right, so we've got 240 meters cubed. We have to put it into kiloliters. What does this right here say? 1 kiloliter is 1 meters cubed. So if we have 240 meters cubed, we would have 240 kiloliters. They're the exact same measure. Okay? So if we have 240 meters cubed, we have 240 kiloliters. How about if we have to measure it in liters? Look right here. 1,000 liters equals 1 meters cubed. All right, so if we've got 240 meters cubed, we have 240 here. How many liters are we going to have? It takes 1,000 of these to make 1. So we're going to have 240,000 liters. Okay? Takes 1,000 liters to make 1 meters cubed. If we have 240 meters cubed, that means our liters is going to have to be way bigger. You're going to multiply times 1,000 is what you did. And if it helps you, you can set these up in a proportion. We could have put it like this. We could have said 1 liter equals 1,000 milliliters cubed. Not milliliters. Meters cubed. All right, and then we had 240 meters cubed. No, I didn't do that right. I got it backwards. Got it backwards. It's 1 meters cubed and 1,000 liters. All right, and then we had 240 meters cubed. And then we needed to know the new liter, so then you could multiply. So if it helps you, take your formula that you've got here, put it in a proportion, and then put over on the right side what you know, and figure the one that's the unknown. All right, I would ask you guys if you have any questions. Does it make sense? I wish I could hear an answer, but I can't. But you know my name and you know my number. You know where to find me if you need help. If something doesn't make sense, please ask. Please ask. Looking over the rest of your lesson, remember how to find 6 and 7. Remember to find prime numbers of the top number and the bottom number. Cross out what's the same, and that gives you your answer on the end. Remember your prime numbers. 2, 3, 5, 7, 11, 13. Those are all your prime factors, okay? Remember those. Number 19, you're finding circumference of a circle. Remember, circumference equals pi times what? 20 and 21, they tell you round to the nearest tenth. You know where the tenth is? One place after the decimal. That means you're going to have to go at least 2 places and then round. 22 and 23, you're supposed to round to the nearest thousandth. 3 places after the decimal. So that means you're going to have to go 4 places and round to 3. Okay? Number 24, they have you an interest percent at 9 3/4. You're going to have to figure out what is the percentage of 3/4. What is 1/4? What is 1/2? What is 3/4? Remember, if you don't know, take the denominator into the numerator, divide, and you'll come up with that percentage, okay? Take the denominator and divide it into the numerator. Let's see. All right, at the bottom of page 64, number 37 is off of today's lesson. You're going to be filling in a few of the blanks. And if you go back to these right here, your formulas here that they have on that page that we were just at, on page 60, right here you should be able to fill in your box on the bottom. 20 centimeters cubed is how many milliliters? All right, well right here they tell you 1,000 centimeters cubed is 1,000 milliliters. They're exactly the same, okay? So if you've got 20 centimeters cubed, that means you have 20 milliliters, okay? So just follow that and you should not have a problem filling in those blanks. If you do, please let me know and we'll see you tomorrow.